Hello, this is third class of AI agent lectures. So we're gonna talk about AI agents theory. So think about language models and AI agents. So transformer-based, non-transformer-based are exist. So transformer-based LLM, large language models, focuses on processing words and tokens. So for example, Meta's LCM, large concept model, focuses on processing sentences and ideas. This is transformer-based. And LQM, large quantitative models, uses transformers to analyze structured data. So, support for AI agent part, this enables AI agents to understand language, process concepts, and analyze large-scale data. Supports tasks like translation, reasoning, and prediction. However, non-transformer-based Recurrent AI's RFM, Recurrent Foundation Model, inspired by warm nervous systems, so focusing on real-time adaptation and continuous learning. Other architectures include RNNs, LSTMs, and biological-inspired models like recurrent neural networks. Enhances agents in adaptive decision-making and time-sensitive tasks, combines with transformer-based models for hybrid architectures. So, autonomous AI agents. There are three types of AI. First one is perception AI. Focuses on understanding image, words, and sounds. Interprets data from sensors or other inputs. Forms the foundation for recognizing patterns and extracting information. So in AI agent part, provides sensory capabilities to AI agents. Helps in environmental awareness for decision making. So for example, if you want to use Vision Pro in like augmented reality environment, you need to use perception AI. Next one, generative AI. Specializes in creating text, image, and sound. Produces content similar to human-generated work. Used in applications such as writing, art, and music creation. Enables AI agents to generate responses or solutions. Supports communication and creative tasks. And then, physical AI. Capable of proceeding, reasoning, planning, and acting. It is designed to interact with the physical world, the real world, can perform tasks autonomously and adapt to real-world challenges. Forms the core of autonomous AI agents, allows AI agents to execute actions in the real world. So, what is autonomous AI agents? Definition is clear. Autonomous AI agents are systems capable of performing tasks without direct human intervention. They operate based on predefined rules and learned knowledge. These agents can independently analyze data and make decisions. They are designed to achieve specific goals in dynamic environment. Key features: ability to perceive the environment through sensors, capacity for autonomous reasoning and decision making, capability to learn from experience and adapt to changing conditions, execution of actions in real time to achieve objectives. So, how can we apply? Used in autonomous vehicles for navigation and traffic management, applied in healthcare for diagnosis and personalized treatment plans, deployed in finance for trading and risk management, utilized in manufacturing for automation and quality control. But there are a lot of challenges. Ensuring security and robustness against malicious attacks, addressing ethical concerns and bias in decision making, managing accountability and responsibility for autonomous actions, balancing human oversight with independent operation. So, types of autonomous AI agents: simple react agent, planning agent, and learning agent. So simple reactive agents is respond to environment based on predefined rules. For example, thermostat turns head on when cold. And planning agents can think ahead and create sequences of actions. Examples: delivery robot planning alternative route. And learning agents improve over time by learning from experience. For example, LLMs helping agents understand past interactions. So, we need to think about react. What is react? It is reasoning and acting in language models. So, for example, maybe you have question, and then react, there are thought and action and observation. So, for example, if you make a prompt, I can say template. So today is type of variables, and you can use tools to get new information. Answer the question as best as you can using the following tools. Then we're gonna give tool description by using variable parameters. So use the following format. Question: the input question you must answer. Thought: comment on what you want to do next. Action: the action to take exactly one element of the parameter. That means tools. So action input, the input to the action, then observation, the result of the action. So this thought, action, input, observation repeats n times. Use it until you are sure of the answer. So thought, I now know the final answer. So final answer, your final answer to the original input question. This is the base template of the React. So let's think about assistant, from assistant to agent. Assistant, augmenting human work. Copilot, suggesting next steps. Autopilot, taking over specific tasks. Agents, orchestrating multiple steps. Okay? So assistants get from here to agent is the goal. So we can make 4 section. So assistance, again, augmenting human work. This is the baseline. And then next thing, we can use Copilot, suggesting next steps. It's improved from assistance, right? And then Autopilot, taking over specific tasks. Finally, it develops as agent, orchestrating multiple steps. So let's follow IBM lectures. So types of AI agents, there are a lot of aspects. Simple reflex agents, model-based reflex agents, goal-based agents, utility-based agents, learning agents. So, simple reflex agent acts based on current perception, follows predefined rule, lacks memory and interaction. Capability is response to conditions limited to fully observable environments. And use cases is thermostat with a set schedule. So it's a little bit useless for us. So next thing, model-based reflex agents. Its type of maintains an internal model of the world, updates model with new information, stores memory for partially observable environment, handles partial observability, adapts to changing conditions. So robot vacuum avoiding obstacles is the use cases of this type of AI agent. So next thing is goal-based agent. Searches for actions to achieve goals, plans actions before execution, improves effectiveness through planning. So use goals for decision making, improves efficiency through planning, navigation system finding, fastest route. Next thing is utility-based agent. Maximize utility or reward. Calculate utility using a function. Select optimal actions based on criteria. So capabilities is optimize outcomes based on utility, balances criteria for decision making. So navigation systems optimizing fuel and cost, and learning agents. This is important. Enhance knowledge through learning, adapts to unfamiliar environments, combines learning, feedback, and problem solving, adapts to user preference, improves performance with feedback. So e-commerce recommendation system is use case. We're gonna use this next time. So now let's get into the AWS data types of AI agents. They define a little bit different. There are hierarchical agents exist. So simple reflex agents is operate based on predefined rules, and immediate data do not respond to situations beyond a specific events, condition, action rule. It's same with IBM's thinking. Suitable for a simple task requiring no extensive training. So for example, resetting password by detecting specific keywords. Model-based reflex agents, it's also similar to simple reflex agents, but with advanced decision making. Evaluate probable outcomes before making decisions. So build an internal model of the world they perceive. Use supporting data to improve decisions. How about goal-based? Is have robust reasoning capabilities, compare different approaches to achieve desired outcomes. Always choose the most efficient path, suitable for tasks like natural language processing, NLP, and robotics. And how about utility-based agents? Use complex reasoning algorithms, compare different scenarios and utility values. Choose scenarios with maximum rewards. For example, searching for flight tickets with minimum traveling time. That's good. And learning agents continuously learn from previous experiences, adapt learning elements using sensory input and feedback. Use problem generators to create new tasks, improve from collected data and past results. Now, hierarchical agents. Organized in tiers of agents. Higher level agents deconstruct tasks into smaller ones. Low level agents work independently and submit reports. Higher level agents coordinate collective goals. Always I told you 1,000 times we need to make subtasks into smaller one. So next thing is Salesforce. Salesforce aspects a little bit different. Of course, mainly is same with the other things. So I'm gonna talk about No, I'm not gonna talk about Salesforce types of AI agents. I think is not. You don't have to know about that. If you wanna know, just give a comment. Then I'm gonna make a video, or I'm gonna write a comment about Salesforce types of AI agents. Okay. And also deep learning.ai is also not useless, I think, because these things same approaches. So how about think about stateless agent, stateful agent, Letta. Have you heard about that? So if you are a prompt engineer or context engineers, whatever, you're gonna get prompt, and this gonna get into the context window, and it's gonna go to LLM. But stateful agents a little bit different. Useful agents maintain state and learn over time. So state, context completion, context window is going to LLM, but LLMs is going to state again. So there's a loop. So stateful agent Letta is concepts of this LLMs plus database plus context management, stateful agents. Ta-da! So the future of AI is stateful agents that learn from experience. However, there are limitations. Large language models possess vast knowledge but are trapped in an eternal present moment. They cannot form new memories or learn from experience because they are stateless. If you are a programmer, you can understand what I'm saying. And advancement, the next major advancement in AI comes from LLM-driven agents that learn from experience. So at LEDA, these systems called stateful agents maintain persistent memory and learn during deployment. So the characteristics, a persistent identity provides continually across interactions, active formation and updating of memories based on experiences. Learning via accumulating state influence future behavior. An implication, this represents a fundamental shift from stateless workflows to agentic systems that learn from experience. It distinguishes stateful agents from LLM-based workflow. So inquiry, ask if the mentioned agent is a stateful agent. If not, ask why. So you need to search about stateful agent LETTA, L-E-T-T-A. Okay? So we already talked about react, reasoning and action, and ReU, reasoning without observation. So we don't have to talk about this again, but it's the part of this lecture. So you need to retrospective about that information. So AWS defines the AI agent works like determine goals, acquire information, and implements tasks. But actually, those things are same. The AI agent receives a specific goals from the user, and it plans tasks to make the outcome useful. It breaks down the goal into smaller actionable tasks. I've told you 1,000 times. The agent performs tasks based on specific conditions. And acquire information. Agents need information to act on tasks. For example, extracting logs to analyze sentiment. So agents may access the internet to retrieve information. That's why we need to know about log, retrieval, augmented generation. Some agents interact with models or other agents for data. It's A2A. And also, if we have sufficient data, the agents methodically implements tasks. Completed tasks are removed from the list. The agent evaluates its progress using feedback and logs. It may create new tasks to achieve the final outcomes. So, also Salesforce talks about how does an AI agent work, but I'm not gonna talk about Salesforce step and these descriptions because they are but I'm gonna talk about perception only perception. So AI agents gather data from a variety of sources, right? Sources include customer interactions, transaction histories, and social media because it's Salesforce aspect. So this data helps understand the context and nuance of queries. Advanced agents integrate and process data in real time. So most of steps and descriptions and specs are same, so we don't have to talk about continuously. So how to use and build agents for work? In the case, Microsoft says like that. There is a 8 steps aspect. So first one is agent creation in Microsoft 365. It's useless, I think. The next thing is Copilot Studio. And the third one, new agent functions in Microsoft 365, Microsoft Dynamics 365, SharePoint integration, Azure AI Agent Service, OpenAI's O1 series, LinkedIn integration. But I think those things are useless. I mean, you don't have to know about that. Just search it if you want, but I'm not gonna recommend about that. So there are 3 types of computational logics. Okay, think about hard coding. Hard coded, it's a traditional if then else loop and function based logic. So logic is explicitly programmed by developers. Rules are predefined and static, well suited for deterministic task, requires manual updates for logic changes. So it's a basic programming skills is needed for as a computer knowledge. But machine learning is logic is learned from data and patterns. Logic is data-driven and adaptive. Models learn from large data sets, effective for tasks with complex patterns or unknown rules. May require substantial data pre-processing and training. So you need to have deep knowledge about computer knowledge. How about prompt engineering? So logic is embedded in natural language prompts or queries. So logic is expressed through human readable prompts. The natural language. So provides a user-friendly interface for interacting with AI systems, allows for fine-tuning AI responses with tailored prompts, can be less flexible for tasks with no prompt-based solution. So minimum computer skill, instead focusing on prompt engineering. So, So I can say about machine learning vs prompt engineering, but I think I don't have to talk about this too. If you wanna know about that, just give a comment, because in my opinion, prompt engineering is also outdated. Machine learning, thousands of the before. No, never mind. I think I'm gonna take a lot of swears from people. So anyway, summary. 3 levels computational logic: hard-coded logic, traditional AI, and generative AI. Approach: predefined rule, hard-coded logic. and adaptability, none. Input type, structured. Output type, deterministic. Example, traffic lights, calculators. How about traditional AI approach? Learn patterns from data. Adaptability, moderate. Input type, structured, unstructured. Output type, probabilistic. Examples, spam filters, predictive models. And generative AI approach, interactive content creation via prompt. Adaptability, high. Input type, unstructured. Output type, probabilistic, creative. For example, ChatGPT, DALL-E, AutoGPT. So how to program? What is program? Let's think. What is program? Let's think. How can we make computational thinking, so logical thinking? So there are two types. First one is procedure oriented. If you are a developer or programmer, you've gonna heard about that before already a lot of times, procedure oriented. For example, C or shell script or R language, Perl, Fortran, Pascal, like that. However, another one, object-oriented. Object-oriented is a most of them. JavaScript, Python, Java, C++, Scala, C#, Swift, Objective-C. Note, JavaScript is object-based and is not a true object-oriented programming language, actually. Anyway, so most modern programming languages are object-oriented because simple class aggregation, inheritance plus aggregation, exception handling must have it. So they want generic programming and UML design patterns. So this is the key points. So you need to think about that. Okay. However, procedure-oriented, there are logic, basic concepts, source. This is the first milestone. Declaration, output and input, arithmetic operators. Then you need to make flowchart, trace table, program control flow and loop. And then control flow source, this is second, and loop source, this is third milestone, and function, this is fourth milestone, and 1D array, fifth milestone. So this is the difference with procedure-oriented computational thinking and OOP. So how to program again? Types of computational thinking: recursive-oriented, LISP, RISP, and hardware-oriented, distributed computing, and generative AI. So generative AI is natural language wrapped by a high level in engage like Python. So how to teach? Just prompt engineering. And recursive oriented, a little bit different. So LISP is used to implement artificial intelligence algorithms, recursive functions. And assembly program is procedure-oriented, but hardware knowledge is required program. So rhythm and computer, LMC, online LMC simulator, alternative LMC simulator. And how about distributed computing is programming language is Spark, MapReduce. Learning from first drawing MapReduce tables, and MapReduce is framework which requires the concept of parallel programming. Several languages can be used to implement MapReduce algorithms such as Java, Python. So you need to know about that computational logic, and then you can use the AI agents because it's the basic characteristics, and then you can implement about AI agents. So next time I'm gonna talk about 3 types of computational logic and AI agents use cases, and how can we use computational logic in healthcare as an example, and education and final services. So no-code AI agent implementation also is possible. So we're gonna talk about Zapier or Microsoft Power Automate like that. So this is gonna next time thing. Okay, thank you. Bye. Oh my god. Okay.